In just 12 minutes, let's build an application leveraging Particle's Smart Wallet as a service for account management, along with Pimlico's Alto Bundler and Verifying Paymaster for sending user operations. So if you've been keeping up to date with some of our recent announcements, you may have noticed that we announced the collection of our native account abstraction technology into something that we call Smart Wallet as a Service. Essentially, Smart Wallet as a Service enables MPC TSS-based onboarding through social logins, directly facilitating the creation and utilization of a specified and built-in smart account implementation. So either a user or developer can say that they want to use Biconomy, CyberConnect, or Simple Account, stuff like that, all natively supported within Particle's Wallet as a Service. This makes it significantly easier to build ERC 4337 enabled experiences, as you can dictate both onboarding, account management, and even things like sending and managing transactions natively within Particle. So one integration to enable full stack end-to-end utilization of account abstraction. Although at the core of our Smart Wallet as a Service is modularity. We really wanted to enable our Smart Wallet as a Service to fit into any part of the account abstraction tech stack that a given developer might need. For example, in the video today, using Particle for onboarding and account management, and then manually facilitating interaction through Pimlico's Verifying Paymaster and Alto Bundler. So let's jump right into it. To quickly set some expectations, we're going to be building a pretty basic web demo today. Essentially, the goal here will be to number one, leverage Particle's Smart Wallet as a Service to facilitate the initial onboarding via social logins with MPC TSS. Then, of course, that will directly tie into the creation and management of a smart account, which we'll use to manually build, sponsor, and execute a user operation with Pimlico's Bundler and Paymaster. So, as usual, we can get started by importing a few base libraries. To start, of course, we can do React and use state along with use effect. We can also import ethers from ethers. We can import our sort of master Particle configuration object as Particle Network, and that'll come from at particle-network/auth. Additionally, to connect Particle with ethers, we can import Particle provider, which will come from at particle-network/provider. Additionally, we can import some things from VM. That'll be create public client, create client, and HTTP. We can also import some things from permissionless. That'll be get account nonce, get user operation hash, and bundler actions. And then specifically within the Pimlico module of permissionless, we can import Pimlico bundler actions and Pimlico paymaster actions. That'll be from permissionless/actions/Pimlico. We can also import smart account from at particle-network/AA. We can also import goearly from VM/chains. Finally, we can import notification from anti. Then to close it off, of course, we can throw in our CSS. All right, so that's all of our base libraries installed. We can move on to creating the main app component containing all of the functions within this application. We'll have everything from the actual logic behind retrieving balances, deploying the smart account, configuring Particle, all the way down to, of course, the actual JSX for displaying all of this. This will take roughly 120 lines of code, but it's pretty straightforward overall, so let's get started. And begin by defining a few different states. To start, that'll be user info and set user info. We can also do ETH balance and set ETH balance, as well as smart account. And finally, we can do is deployed. All of these different variables will come into play in a moment. So let's open this up by doing some initial configuration of our Particle object. We can save this in an object called config. Config will contain three different attributes. This will be project ID, client key, and app ID. But before we set these, we'll need to head over to the Particle dashboard, create a project, and retrieve them. All right, so as you can see, I'm now on the Particle dashboard. I can click on add new project. I can name this Pimlico video. And then in here, we'll need to create an application. Of course, in my case, I'm building a web app. So I'll select web. I can name this Pimlico demo, and then throw in the domain in which this application is being hosted. All right, so now I can go ahead and grab the project ID, the client key, and the app ID. And then of course we can throw all those into environment variables and continue. So of course in the config object here, what I'll do is I can define project ID as process.env.react app project ID. I can do the same for client key as well as for app ID. All right, so now with our config object defined, we'll need to create two different variables. The first will be Particle, and the second will be smart account Biconomy. So let's start with Particle. We can set this equal to new Particle network. Then we can pass in config, and of course we can fill in a few additional parameters, such as the chain name, which in this case is Ethereum, as well as the chain ID, which will be 5 because we're doing this on Ethereum goearly. And we can also open up wallet here, which will be an object. And in this case, we can just set one configuration, which will be display wallet entry. This will basically tell Particle to throw a little pop-up with the wallet UI to the bottom right corner of the screen. Additionally, for the smart account side, we'll need to use Particle's account abstraction SDK to manage a specific smart account. Now, one thing to note with Particle is that you have total flexibility over which smart account implementation you choose to use. In my case, I'll be using Biconomy. So I can name the variable smart account Biconomy and set that equal to new smart account, which will take a provider object, in this case, new Particle provider, which itself takes particle.auth. And then we can open up some configuration right here. We can pass in our config object, and then we can also open up AA options. And in here is where we can define the specific specific smart account implementation that we'd like to use. In this case, we can do Economy and set the chain ID to 5 and the version to 1.0.0. Before we continue on to creating the core logic behind the application, let's first do particle.set ERC4337. And in here, what we can do is essentially tell the wallet pop-up itself to go ahead and open the UI to a specific account. So in here, I can do name, and that'll be, of course, Economy, and then I can set the version to 1.0.0. So let's now move on to, like I mentioned, creating all of the core logic behind the application. So we can start by creating an Ethers provider instance. This will again use Particle Provider to directly connect Ethers with Particle's wallet as a service. So we can save this in a variable called provider and do new ethers.providers.web3 provider and pass a new Particle Provider, which takes particle.auth. So with provider defined, let's go ahead and open up a use effect. And within this use effect, we're going to define one major function. This will be fetch account info. And within this function, we'll need to basically set 3 different things. The first will be the smart account state. The second will be the get balance state. And the third will be a Boolean reflecting if the smart account is deployed or not. So let's start by opening up a variable called smart ac. And this will just be the address of the smart account that we just initialized. So we can do await smart account by economy dot get address. Then of course we can do set smart account and throw in smart ac. Also go ahead and pull the balance of that smart account. We can do this in balance and do ethers.utils.format ether, and then within format ether, call await provider.getBalance, and then pass in smart ac. Then of course we can do set eth balance and pass in balance. Finally, we can call set is deployed and check if the smart account is deployed with await smart account by economy is deployed. And then of course, now we can call the fetch account info function itself, but it should be on the condition that user info is defined. All right, perfect. Let's move on to creating the logic behind our account deployment button. We can call this deploy account. We can basically do a one-line conditional checking if smart account by economy is deployed. And if it isn't, then we can do await smart account by economy deploy wallet contract. Essentially, all this will do will create a pop-up that we can then sign that'll push a contract deployment transaction through and thus deploy the smart account. Let's also go ahead and create the logic for handling the social login aspect of our application. That'll be handle login, and it'll take one parameter called preferred auth type. And again, another pretty simple one. We can just create a variable called user and do await particle.auth.login and pass in preferred auth type. Then we can close it off by doing set user info and user. Okay, so we've now built out around 90% of our application, but now we're moving on to the largest function yet, which is execute user op. In this case, we're going to manually build, sponsor, and send a user operation. And we can start by getting the signer or the owner address of our smart account by saving it in a variable called signer and doing provider.getSigner. We can also go ahead and define our entry point, and that'll be this address right here. Okay, so let's now go ahead and create 3 different clients: the public client, bundler client, and the paymaster client. We can start with the public client. That'll be create public client, which will take transport as HTTP, then process.env.react app RPC URL. This is just an Ethereum Go Early RPC URL, and we can also set the chain to Go Early. Let's also go ahead and spin up the bundler client. And this will also take transport, which in this case will be the Pimlico API endpoint set as v1 and Go Early. And then of course we can fill in the API key parameter right here. But before we do that, let's head over to the Pimlico dashboard and actually create our API key. All right, so I'm here on the Pimlico dashboard. I'm going to head over to API keys. I can go ahead and generate a new one, and I can name this demo video. From here, I can go and copy this, then throw it into an environment variable within my application. Then I'll also pass in chain as Go Early, and then we can do .extend bundler actions, which will extend Pimlico bundler actions. We can do the same thing for the Paymaster client. The only difference here is that we're doing v2 and extending Pimlico Paymaster actions. All right, so now with all of this made, let's go ahead and quickly pull 2 key data points that we'll need within our instruction of the user operation. This will be the smart account nonce and gas price. We can set these equal to await promise.all. And then in here, of course, we can throw in our 2 asynchronous functions for retrieving the nonce and the gas price. For the nonce, we can do get account nonce, pass in public client, and open up an object here that has address, and we can also pass in entry point. Now for the gas price side of things, we can just simply do bundler client.get user operation gas price. Okay, so with those defined, we only need one more main data point before we can begin construction of our user operation. And this will be the call data. So of course, in my case, I'm just doing a simple transfer function. This will be a burn of 0.001 ETH. So to go ahead and generate the call data for this, we can first define account and do new ethers.utils.interface. And then in here, we can do function execute call. And of course, execute call takes address 2, uint 256 value, and bytes data. Now we can go ahead and define our call data variable. And here we can throw in the parameters of the transaction that we'll be doing. First, of course, the to address will be this burn address right here. The value will be ethers.utils.parse units, and then I'm not passing in any data. So I can just set data as 0x. All right, so perfect. With all these different variables defined, we can move on to the initial construction of our user operation object. So let's do let user operation. First, we can set the sender. This will just simply be smart account. We can set the nonce, the init code. We can also pass in call data, then max fee per gas, which in our case will be gas price dot fast dot max fee per gas. Then we can also do max priority fee, similar to the last one, gas price dot fast dot max priority fee per gas. And finally, we can close this out by defining signature. We can throw this in as a placeholder signature. We go ahead and throw in this placeholder, essentially hold our signature with something that's technically valid while we're waiting to provide the final signature at the end. So it's actually sponsoring this user operation. Let's go ahead and do that. We can save this in a variable called sponsor result and do await paymaster client dot sponsor user operation. Then we can pass in our user operation as well as the entry point. So this will add a few different attributes to our user operation object and will essentially allow us to send this transaction without paying gas fees. Because of course, in this case, we're sponsoring the gas fees on behalf of the user. So let's now go ahead and update user operation and set that equal to user operation as well as the newly defined sponsor result. Finally, what we can go ahead and do is pull the user operation hash with get user operation hash, which will take user operation, chain ID of 5, and entry point. And now we can go ahead and actually sign this hash, which we can do within user operation.signature. Of course, in this case, we're overriding the placeholder signature that we threw in earlier, and that'll be set equal to await signer.sign message, then ethers.utils.arrayify, and then passing in user operation hash. All right, so now we have a fully constructed and sponsored user operation with a signature from our signer. All we have left to do now is create a variable called user operation hash result to await bundler client.send user operation. This will send the now fully constructed user operation to the bundler itself. And that'll take user operation and entry point. So we can simply throw notification.success. All right, so there we go. We can go ahead and close off our application by opening up a return statement and formatting all of our JSX. I usually skip this part, so I'll go ahead and do that and be right back. All right, so now we've gone ahead and formatted our JSX. As you can see, it's pretty simple. We're checking if user info is defined. If it isn't, then we're displaying our two sign-in buttons. Then if user info is defined, indicating that the user is logged in, then we display their name, their balance in ETH, and then we also check if the smart account has been deployed. If it has, then we display the execute user operation button right here. If it hasn't, then we display the deploy account button right here. So we can go ahead and close this off by doing export default and then app. All right, so there we go. Let's go ahead and run it and see if it works. And there we go. Looks like it worked. We can start, of course, by signing in with Google. In this case, I'll choose this Google account right here. And there we go. Let's go ahead and click execute user operation. We have the confirmation right here. Click on confirm. And there we go. User operation successful. So let's go ahead and copy this, head over to an Explorer and check it out. So there you go. As you can see, 1 minute ago, we sent 0.001 ETH to this debt address. And of course, we paid no gas fees in the process as it was sponsored by Pimlico's Paymaster. If you'd like to learn more about Particle's Smart Wallet as a Service, then I'll have the recent blog posts that we made about it linked below. Additionally, if you'd like to either give the application that we made today a try for yourself or any of our other web demos, also have those links below.